All right, so I'm going to start with going through exam 2 for the problem questions of last year for what Bernard's had problems with. And we're starting with the data. And obviously, what we had problems with is generally what the state had problems with, so that's okay. All right, so the first one that we come across is down here. So here with it says we've got 15%. It said the median weight of the large oysters. I think this is what happened is they just did the median weight of all the oysters. So what you had to do is you had to go back and just get the large ones. So here's the weight of all the large oysters, which I think, and then so you would put them, because there's 1, 2, 3, 4, 5, because if you put 5, the third highest is going to be the median. So if you just went through that, I think, so that would be 1, 2, and you can see 3. So the median was 14.1. I just think that it was just not reading the question correctly. So because the one before you had to find the mean, so everyone chucked, but that was of all the oysters. Here they just asked for the large, which was a little bit of a trap. Okay, this one here, this next question that had trouble with was, it says complete the following sentence. So the equation predicts that on average, each 10-gram increase of weight of an oyster is associated with so you can see we've got the least squares regression line. And this little comment here, it's sounding very much like our when we interpret the slope. So the slope, when you have the slope, the interpret script, if you think about it, has, so this is that interpret script. The only thing is we normally say with one unit increase. So they've actually been a little bit trickier, and they've said with a 10 increase. So when we say, all right, the volume goes up 0.953 each 1 gram of weight, well, they've said 10 grams. So we have to actually times that by 10. And so this is they're just being nasty to try and catch kids up. So you just times it. So just be really careful. They'll probably repeat that because that would have been really poorly done. All right, now down here, we've got this one, and when it says the number of megapixels needed to construct an accurate image of an oyster is normally approximately symmetric. So as soon as you see this here, you know you're using that bell shape. So it's always good to, as soon as I see that word, I just pop it in, and we're going to be doing something like that. Now, they've said, and remember, everything's going to vary around those normal statistics, so those little tails and things like that. So it says here 97.5 of the electronic images contain less. Now, if you think about it, 100 minus 2.5 equals 97.5. So they're at one of those 2.5 pockets. Now, because it said less, I'm going to say, well, it's up here. So if I go 1 standard deviation, 2 standard deviation, I know that this pocket is 2.5%. So they're saying that anything there less is 97, which means I know that at this point is 4.6. Okay, now then they'll give me another one, so I'll just draw it in green. It says 84% contain more. So you can see 100 minus 16, which is another type of tail that we can see, is equals 84. So, but it's saying more than. So I can see if I go down, remember, if I go minus 1 standard deviation, this pocket ends up being 16. So then above it would be 84. So now they've told me that that one is 4.3. Okay, so now that we know that, it's asking us to calculate the mean. So we can calculate the mean. these little sections here, they actually equal, even though it doesn't look too much on mine. So I've got three equal sections between 4.3 and 4.6. So because I know, therefore, then they must be all 0.1, yeah? Because that would be, it would take me up. So when they ask me what the mean is, I go, all right, 4.3 plus 0.1. So the mean must be 4.4, and we've already worked out one standard deviation is 0.1. All right, so they're just poorly done, so it means probably going to repeat again. Okay, with this one, it says we only had 40%. Now, we've been doing it. Now, what happened when I read the examiner's report, I'm not too sure if it's our kids, but it looks good, probably. So what you need to do is when you need to draw that, so this is the least squares line, and they want you to draw it. So remember, we want to use two x-axis points or values. And so the temperatures, two temperatures, and we pop it into the formula. So say consumption equals, now I'm going to pick -10 and 25 for my points. So I'd go 0.1404 plus 0.0024 times -10, and I end up with 0.1164. So that means at -10, it's 0.116. So it's, if you look at it, it's going to be roughly above there, okay? And then if you do the other point with the same rule, 0.0024, but times the 25, that's the other one I picked, and I get 0.2004. So I go up here, 2004. So it's right, it's close to that 0.20 line. All right, so when I read the examiner's point, they said that this was actually done well, like in terms of they could see that kids had calculated the points right. What was done wrong was putting them on here and also drawing it. You must use a ruler. So here I am going to not break the rule, but you need to use a ruler. So it's not like they didn't know how to do it. They did, but they poorly did not draw it on the graph correct. Okay, so the next one on the that was poorly done was here, this F, and it was saying whether you had to predict a temperature of -6, and now what you had to say whether it was extrapolation or interpolation. So going back to here, this is where you have to look. This, when it's going to be interpolation, I'm going to do it in green. So interpolation means you go from your first dot and your last dot out here. So anything predicted in here would be interpolation. So it's within your data, interpolation, within your data recording. Now, anything on the bit outside, so anything out here or out there, any number that's out that way will be extrapolation. And so here's extra. Now, it was actually -6. So you got to remember, -6 is going backwards that way. So -6 is there. So that one is actually extrapolation. I think maybe this was done poorly. Maybe I think most people would know what interpolation, extrapolation is, but they might have got tripped up by -6 is actually further going the other way. So that could have been an issue there. All right, so moving on here, the next one that we had a problem with was here. Now, it says identify the feature of this plot that is consistent with the time series having seasonal component. So just to show you, like if you had to describe anyway, we just say we had to say describe this time series. So because the seasons, they're talking about months. So how many months do we have in a year? We normally have 12, yeah? So what we're going to do, what you should be doing, so because the seasons are months, what along the underneath, I'm going to do months. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Then I'm going to start counting again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then I'll go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, yes, this does have seasonality because can we see the same thing? At every 6 months, it's peaking. So, at the 6, every 6. So it's actually every year at halfway through the year, we're peaking. So when it says what is the feature, you just had to say that. So because it's seasonality, because the maximum value occurs, it's occurring every year or every 12 months apart. And you can say maybe at the 6th month. But they're actually 12 months apart, aren't they? Between every like say if you said that was June, every June it's peaking. So that's how you explain the the seasonality. So you needed to write something like that. So you probably need to have this example in your book because it's probably going to be, I reckon this would have been poorly done. So you'll probably get another sort of thing like that. All right. So just to remember how to maybe describe what seasonality is. Okay. This last one, 35%. So it said show when rounded, the seasonal index for July 2011 is estimated from this data is this. So if you first of all go, all right, I need seasonal index. So if I wrote out the formula for seasonal index, the way you find that is you do the value of the season over the seasonal average. So what we're going to do is, so if you think about it, if you've got it, so we need to find it for July. We can see that the actual, they're giving us the actual there for July is 0.183. And we also need to get the season average. So remember that the season average, this is when you add all of the seasons up and you would divide that by 12. So you end up with, this one ends up being 2.004 divided by 12. So it is 0.167. So I can pop that down over in my formula now. And if you do that, so you probably had to, because it's saying show, all right, so, and then that equals 1.10. So you probably have to also show, yeah, I don't know if this would be enough. Maybe write this out a bit more clearer, because so you go the seasonal average, you could have just said, all right, that equals the total, say the sum of the seasons divided by 12, yeah, or whatever. But I think if you'd shown that, you should be right. Okay, so I think because it's a show, it's caught people up.